So now that we've got our entire environment up and running, how much time was that? I think it was like 4 minutes, 5 minutes with me even talking. But this network's not really that useful unless you're doing something, right? So we're going to go ahead and go back to step 1, and we're going to build an example program, and we're going to deploy it to the network to make sure that that's working properly. So we're going to go into our projects folder. So I just created a projects folder in my user directory, but you can put it wherever you want. It does not matter. It's just for convenience. So in this case, I'm just going to create a Arch example program folder, and we'll go into that. And this will just be a placeholder for all of our example programs. And it says to git clone our Arch network / Arch examples repository from GitHub. Once I do that, and this can take a little while. There's a bunch of different examples in there, depending on your internet connection. So I've got a pretty fast one, humble brag, but it happened really quickly. So in this case, we're going to go into our Arch examples. There's an examples folder, and then the Hello World program. So I'll just go ahead and ls that so you can see what's in there. So you got a program folder, a source folder, and a cargo toml, which is pretty standard for a Rust project. Remember, this is all Rust, so if you don't know Rust, I recommend you try and get a tutorial or get used to it if you're not a Solana developer. A lot of Rust. And at this point, we have the source code for our example program, and we need to compile it. Now, this is where we start to use the Solana compiler. So the reason we installed the Solana CLI is because Arch Network uses the Berkeley packet filter compiler that's included with the Solana CLI. So we're going to be using the cargo build SBF command, and we can do that from within the program folder in our source code. So we're going to cd into our program folder, and in there is some source code as well. And so what we're going to do now is we're going to run cargo build SBF, and this is going to use the Solana specific compiler. Hopefully this compiles successfully. In most cases, if you're running your own program, this is where you'll start to see your compiler errors come in, and you can fix your programs and make sure that they run properly. Hopefully, because these things are vetted and before we push them to the repository, it should run without any errors. We do have a warning here, but it did finish. So with Rust programs, you'll see finished, release profile, hello world program generated. So now at this point, what it's done is it's hopefully created a target folder. So if we ls that folder, you'll see target. And within target, there's a bunch of folders that are related to the release compiled binary. But the one that we're really interested in is this one that's in the target SBPF Solana / release folder. So if I just go ahead and ls out that to see what's in there, you'll see in red, there's a hello world program.so. That is our ELF binary. This is basically binary code that our source code compiled into. And this is what we're going to be sending to the Arch network when we deploy a program or a smart contract, as some people are familiar with if you've been developing on Ethereum or other blockchain platforms. In this case, we call it a program. So this looks great. It looks like exactly what we were hoping for. And now we're going to use the Arch CLI to deploy that to the network. And in the tutorial, you'll see we have the Arch CLI command. So we'll do Arch CLI deploy, and then we have to point to the actual folder with that SO file in it. So we're going to do target SBPF Solana. And if you were using Warp Terminal like this, you get some nice command filling. But this is correct. We're going to do generate if missing. So in order to deploy a program, you need an account. In this case, we have a helper option. So you can specify generate if missing, and that will just go ahead and create the Arch account to deploy this program with, and it will just generate it for you. So it'll generate the key and create the account for you if you haven't already done that. You can specify which one you want as an alternative. This is the easiest way to get started. And then we also have fund authority. So it does actually require Arch token in order to deploy a program to the network. And this is basically a helper method for local development that will go ahead and fund the account that's going to deploy this program. It will do that for you. And it's just these are convenience methods. It's very similar to Solana CLI if you've ever used that. It's modeled after that. So we're going to do that, hopefully. So now we see a bunch of stuff streamed by. And we'll just kind of walk through this just so that you can kind of understand a little bit better what's happening here. So we have our command, welcome to the CLI, which we always see. And then we see the profile configuration that we're using. So we're pointed to our localhost node on 9002, which is the default port. We're using our local Bitcoin D node. And then you can also see right after that, we're generating a program key pair and the location of it. So it generates it in that release folder. It's a JSON file with our key pair in there. We're also generating a new authority key pair, which is the program that's able to deploy the account. So we have the program key pair, which is going to be the account that stores the ELF binary on chain. And then we have the authority, which is the account that is actually in control of the program, can control ownership of it, things like that. We next fund the authority account because we asked it to fund that. It was successful. And then we start to see the program deployment itself. So we're deploying the Hello World program. It goes through a bunch of stuff here that's maybe familiar to developers that are in more advanced step. But step one is to create the program account on chain. And we have a transaction ID here. We have the program pub key. Here's the pub key that's for the actual program that we're deploying. And we can see these on-chain logging coming through here. That's not so much important to us right now, but we see truncating the program account to the size of the ELF file. So we want to make sure that we're not paying extra fees on-chain for storing too much data. The ELF file is a finite size of data, and so we want to make sure we limit the account to that size. We see some other network accounts. Then we see sending ELF file as transactions, 31 of 31. What this means is when we actually send a transaction to the network, there's a data size limit. And so we can't just send a 2 megabyte, an 8 megabyte, 5 megabyte binary file to the network in one transaction. So the Arch CLI will actually break it up into chunks and submit those chunks piece by piece to the network in order to comply with that restriction. So in this case, this Hello World program is pretty small. It generated 31 chunks. And that's what we sent. And it looks like that was successful. The next thing that happens is, in this case, is we're going to actually set the ownership of the account. And so that's what step 2 does, and that was successful. Step 3 is to actually make the account executable. So there is a concept of an account on Arch where it's actually just a data account, so to speak, or it's an executable, which means that it's actually a smart contract or an Arch program. In this case, we obviously want it to be an executable program, and so that is actually done through another transaction, or an instruction rather. And the program was done. So down here at the end, we have the program account information. So we have account pub key, we have the owner, we have whether it's executable. And in this case, there's no UTXO details, but a lot of times when we're doing transactions on the network, there will be a Bitcoin UTXO associated with that. It would be listed here if that's the case. And then we can see the ELF size. So in this case, it's about 293K kilobytes. And here's the final pub key. So that right there hopefully gets you familiar with deploying a program to the network. Now, what I'm going to do is I'm going to go ahead and show you that we're going to actually verify that the program is on chain, because we always don't trust. We already trust but verify, right? So in this case, we're going to trust that it happened, but we're going to verify through some commands. In this case, we can use the Arch CLI show command. One thing to note is currently the Arch CLI outputs a hex string for your program pub key, and that's not going to work. So what we can do is we can just go ahead and convert it to base 58, which is what we need. So I'm going to paste that pub key as hex into this online converter and get base 58, and we use that in the next command. So Arch CLI show, and we'll paste in our program pub key, and you can see this is like basically binary. This is the binary file. It's huge. It's 240K roughly. So we'll go ahead and see where the beginning of it is. Yeah, so show command. We can see that here's the pub key. We can see that it has a balance of Arch, which is what we need to do. We need to fund it so that it can exist. We can see the owner. We can see that it's executable. It's not associated with the Bitcoin output yet. and then the data, which is the raw binary of that ELF file. And if you compared this hex code with the actual hex of the binary, you would find out that they're exactly the same, and we can see the ELF size is correct. So at this point in time, the Hello World program that we deployed with that account is on chain and ready to go. And we can interact with it however we like. And so that right there is a start to finish tutorial on how to deploy your program to the network. You would basically repeat the same similar steps to do that with your own program. You would create a Rust file, cargo build SBF, generate the binary, and deploy it to the network. Keep in mind that all of this is done through the Arch CLI for convenience, but you can actually write Rust code to do all these steps separately, and you can find examples of that in our Arch examples repository on GitHub.